Hello. We now take up questions on midpoint theorems and the converse of midpoint theorem. Before moving on with problems, we discuss the midpoint theorem first. I write down what the midpoint theorem says. Midpoint theorem. Oh, it's a spell mistake. Yeah. The theorem says the line segment joining the midpoints of any two sides of a triangle is parallel to the third side and equal to half of it. So we join the two midpoints of these two sides. These suppose are the midpoints. I'm imaginarily drawing the midpoints. I have joined them. It says, if I name even them as A, B, C, and this being D, E, it says D and E are midpoints of A, B, and AC. Then this line segment, that is DE, is parallel to BC and it is also half of BC. So I write here as given. A triangle ABC in which D and E, they are the midpoints of sides AB and AC respectively. We have joined D, though we have to rather prove here that DE is parallel to BC. We also have to prove DE to be half of BC. To do so, we'll have to extend this DE and join C. This is, it doesn't look like this, more or less looks like we have joined this FC as well as EF. The proof starts here. We try to prove the congruency of triangle AED and triangle CEF. Okay, if we do so, if we can prove the congruency, we can say that AD will be equal to CF. Let's see. As because we also have extended DE, which was already okay, we have to prove that anyways. I continue with this angle AED, isn't it equal to angle CEF, they being vertically opposite angles. These two are. AE is also equal to CE, as it was given that E is the midpoint of AC. We have drawn this construction that DF is equal to EF when we joined that. Thereby making SAS congruency rule to prove AED congruent to CEF by SAS rule. Once it is done, we were supposed to actually, we are doing so to prove AD equals CF by CPCT. As because now AD, therefore angle ADE will also be equal to angle CFE. I mean these two, let me mark this and this. D is also the midpoint of AB, thereby making AD equals DB. AD was equal to DB and AD is also equal to CF, thereby making DB equal to CF. Now this and this. Now ADE and CFE angles as were equal here. If you see, they make alternate angles, aren't they? Yes, they are making alternate angles, thereby making AD, this line, parallel to FC. If you cannot observe, let me highlight it, how they make alternate angles. See, this is how they make alternate angles, thereby proving AD to be parallel to FC. Oh, so therefore DB will also be parallel to FC. I write this, we got this, this is suppose A, I also got this as B. As because we got these two angles equal, we know that DB is also parallel to CF. Therefore, DBCF, see this one, DBCF is a quadrilateral such that its one pair of the sides are equal and parallel as well. We have proved DB to be equal to CF. We have now proved DB to be parallel to CF, both parallel and equal, thereby making this whole thing a parallelogram, right? This DBCF. We have proved them to be equal. We have here proved them to be parallel, thereby making DBCF a parallelogram. Once this is a parallelogram, that means opposite sides are parallel. So DF, that means, is parallel to BC. And DF is also equal to BC. This one, DF is equal to BC as well as parallel to BC. Now DEF, they are all collinear points. Therefore, DE is also equal to EF and DE will therefore be parallel to BC as well as half of BC. This is the theorem of midpoint. The converse theorem says if the line drawn through the midpoints of one side of a triangle which is parallel to the third side, that means if you are drawing the midpoint from D and is parallel to the side BC, then E is also, it intersects also the third side at midpoint. That means E becomes midpoint automatically. That's the converse of the midpoint theorem. Let's see some application of midpoint theorem. I write down a question here. Before doing so, let me draw the figure. The question says D, E, F are the midpoints of BC, AC and AB respectively. Of an equilateral triangle ABC. Prove that DEF is also an equilateral triangle. So it's given ABC is an equilateral triangle and FED are the midpoints. Okay, now we know that F and E are the midpoints of A, B and AC. Similarly, DE is the midpoint, so they all are actually half of AB. If what the midpoint theorem said, the line joining the midpoints of any two sides is parallel to the third side and is half of it. That means what? FE is equal to half of BC, as well it is parallel to BC. Similarly, DE is half of AB. It is also parallel to AB. FD is half of AC and FD is also parallel to AC. It had said that AB, BC, CA, they are all equal, right? It's given to be an equilateral triangle. So half of AB will also be equal to half of BC, will also be equal to half of AC, since AB is equal to BC is equal to AC. What is half of AB? That is half of AB is DE, therefore it's equal to EF and then it is equal to FD, thereby making FDE as an equilateral triangle. Hope you followed. Thank you.